Hello everyone, and welcome to this series of videos where we'll be learning a little bit about the chemical nomenclature, which is basically the study of how to name the chemical substances. As we have names, chemical substances also have names, and it's necessary to learn how to name them. So, to start, let's divide the chemical elements into two big groups, the metals and the nonmetals. Let's choose one metal element, such as sodium. When we have these metals, we can mix them with oxygen to produce a basic oxide, so like sodium oxide in this case. Now, let's think what happens if we mix the sodium with hydrogen. We will have a metallic hydride, like sodium hydride. If we mix now this basic oxide with water, we will have something called an hydroxide, like sodium hydroxide. Now, let's go to the nonmetals, and let's think one nonmetal like sulfur. If we mix sulfur with oxygen, we will have an acidic oxide, not a basic oxide anymore, but an acidic oxide, like sulfur trioxide. And if we mix this sulfur with hydrogen, we will have a nonmetallic hydride, which is also an acid without oxygen. In this case, hydrogen sulfide. Now, let's go back to the acidic oxide, and let's mix it with water. And here, we will have an acid with oxygen. In this case, we will have sulfuric acid. And in the end, if we mix the hydroxide with this acid with oxygen, we will have an oxysalt, like sodium sulfate. And if we mix the hydroxide with a non-metallic hydride, we will have an haloid salt, or a salt without oxygen, like sodium sulfide. Very good. Now, to start, let's focus on these basic oxides. To start, remember that the metals could be in group 1 metals or alkali metals, and let's see that all of them have an oxidation number of +1. Now, the group 2 have an oxidation number of +2. And look that the transition metals here, one of the properties is that they have multiple oxidation states. Now, let's focus on these examples on iron, copper, and, for example, zinc. Now, let's think what happens when we mix or when we make react a group 1 metal with oxygen. And what is the product? Now, let's start with sodium. Now, sodium reacts with oxygen to produce something. We know that when we mix a metal with oxygen, we will have a basic oxide. Now, the oxides have this structure: metal followed by the oxygen. Now, there's something missing here. And we know that when we have a chemical equation, we have to take into account two things: to balance the charges and to balance the mass. Let's balance the charges here. The product. We know that sodium has an oxidation number of +1. And we know that the oxygen normally has an oxidation number of -2. We need to make this formula to be equal to 0. So we have a +1 here and we have a -2 here. To make it neutral, we need to turn this 1 into a 2. But we cannot just say, okay, now sodium has 2. No. The thing that we can do here is add another atom of sodium. This charge of the two atoms is going to be +2. And now the formula has a net charge of 0. Another thing that we can do is try to do a cross here. You can see that this is a 2, so you put the 2 here. And here we have a 1, and you can put the 1 here. But it's not actually necessary to put the number 1 because it's obvious that we have one atom of oxygen here. So all you can do is just let the 2 there, and this is going to be the final formula, Na2O. And the name we name it is very simple. We say first the name of the cation, in this case sodium, followed by the oxide. Sodium oxide. Now, we have balanced the charges here, but also when we have a chemical equation, we also need to balance the mass. Now, let's see that here we have 2 atoms of sodium, but here we have 1. And here we have 2 atoms of oxygen, but here we only have 1. So, to start, we can see that here we have 2, and here we have 1. So we put number 2 here. And now we have 2 atoms of oxygen here, and 2 atoms of oxygen here. But now, look that we have now 4 atoms of sodium here. 2 times 2. So since we have 4 atoms, we will need to put number 4 here. And now we have the balanced equation. Now let's move to calcium, which is a group 2 metal. In this case, calcium reacts with oxygen to produce a new compound, which has the formula CaO. But we haven't balanced the charges nor the mass. Now let's see the charges. Calcium is in group 2, hence it has a +2 charge, or oxidation number. And oxygen, normally, as a rule of thumb, when they produce oxides, they have -2 as an oxidation number. Now, we can see that +2 minus 2 is 0. So the formula has a net charge of 0. It is neutral. So it's not necessary to put number 2's here doing the cross. Let's see the mass. Here we have 1 atom of calcium, and here we have 1 atom of calcium. But what happened with the oxygen? Here we have 2 atoms of oxygen, and here we only have 1. We cannot put the number 2 here because we cannot modify the formula. What we can do is to put a number 2 here, and now this 2 affects both of them. Now look that we now have 2 atoms of oxygen, and we have now 2 atoms of calcium. So the oxygen is balanced, but the calcium is not. So what we do is to put a number 2 here, and now we have 2 atoms of calcium, 2 atoms of calcium, and 2 atoms of oxygen. Very good. And the name of this is very simple. Calcium, which is the name of the cation, followed by the word oxide. Okay, so this is pretty simple. But now, what happens if we use a transition metal like iron? And look that iron has 2 different oxidation states, +2 and +3. So we could have 2 different compounds. In the case of iron 2+ and the iron 3+, both of them can react with oxygen to produce different substances. So in this case, let's put this formula, which is the cation and the oxygen, and that's it. Let's check the charges. So in this case, we have that iron has a 2+ charge, or oxidation number, and here we have an oxygen, which normally has a -2. So here we can see that the formula is neutral, so we do not have to modify the formula. So the charges are balanced, but now let's balance the mass. We have 1 oxygen, 2 oxygens on the reactants, and we have 1 oxygen in the product. So what we do is to put number 2 here. Now we have 2 oxygens, but iron we have 2 on the right and only 1 on the left. So what we do is to put number 2, and we have 2 irons and 2 oxygens. But what is the name of that? Let's try to do this one here first, and then we will say the answer. So in this case, we will have the same, but now let's check the charges. Iron has a 3+ charge, and oxygen is a 2-. So the charges are not neutral. So what we can do here is to use the trick that I showed you. We can cross the charges. So this number 2 here will be here now, and this number 3 here will be on the oxygen. If you multiply 3 times 2, you will have 6 minus, and if you multiply 3 times 2, you will have a 6 plus. So 6 minus 6, you will have 0 net charge. We have the charges. What about the mass? In the case of the mass, you will have iron that has 2 atoms here, and oxygen we have 3. The only thing we can do here is, since this is a 3 and here we have a 2, we will need to find one number that is a multiple of both of them. In this case, 2. 2 times 3 is going to be 6. And here we put the 3. And here we have 2 and 2, it's 4. 4 irons. And here we will need to put a number 4. What about the names? Here we'll have iron, which is the name of the cation, oxide, right? And here we have iron, oxide. But wait, so we have 2 iron oxides. So how can we difference the iron oxides, since both of them are different species? So the thing here is that we will need to put into Roman number in parentheses the oxidation state of the cation. In this case, we will have iron 2 oxide, and here we will have iron 3 oxide. So we have both of them are iron oxides, but they have different oxidation numbers. So this is something that happens in the transition metals. Same thing in copper. What about zinc? Zinc is a metal that only has one oxidation state. We have zinc, we mix them with oxygen, it reacts to produce zinc oxide, and we know that the oxidation number of zinc, look here, it's +2. So we put the 2 plus and 2 minus, so this is 0. We put the 2 for the oxygen, and we have a 2 here for zinc. So we have balanced the charges, we have balanced the mass, and what's going to be the name of this? So we put zinc, the name of the cation, and oxide. Wait, do we have to put 2 oxide? Well, actually, since zinc only has one oxidation state, it's not necessary to put zinc 2 oxide, since we know that it's the only possible name that it could have. So we only put the Roman number in parentheses when these elements here have multiple oxidation states, like cobalt, nickel, copper, chromium, manganese. One important thing here that is worth mentioning is that there is more than one way to name the chemical substances. This one, in which we put the Roman number in parentheses, is called the stock nomenclature. However, there is another way to name them, and it's called the traditional nomenclature, which is one of the earliest methods of distinguishing between ions. And in this case, we use suffixes added to the Latin name of the element to represent the lower and the higher oxidation states. For example, in this case, we have to focus on the oxidation state, and we have to identify if it is the lowest of the highest. So, for example, in iron, we have 2 different oxidation states. We have +2 and +3. Since +2 is the lowest, we will need to use the prefix "-os" after the Latin stem of the element. For example, iron, the Latin stem is "fer", and we have to use "-os", so it's "ferrous", and that means that in that case, iron is working with 2+, and this is ferrous oxide. On the other hand, if we use the +3, which is the higher oxidation state, we need to use the suffix "-ic". So we have ferric oxide. In the case of copper, copper has 2 different oxidation states, +1 and +2. The lowest is +1, so we use "-os". And the stem of copper in Latin is "copper", so we put cuprous oxide. And for the higher oxidation state, we have copper 2+. So we have copperic oxide. In the case of manganese, we have also, look at this, 2, 3, but we have several oxidation states. So this is not like following a pattern, because the higher should be +7. So let's see what happened after this. So for 2+, we have manganose oxide. And for 3+, we have manganic oxide. For cobalt, cobalt has two different oxidation states. So the lowest is 2+, so we have cobaltose oxide. And the one that is higher is +3, so we have cobaltic oxide. However, look at this. In this case, we have manganese here with +7. And when you have the highest allowed oxidation state, you need to use a prefix per, followed by a suffix ic, and in between you have the Latin stem. So in this case, you have permanganic oxide, when manganese is working with +7. However, this is quite confusing, and now chemists use a simpler method, in which we only put in parentheses the oxidation state of the ion that we're talking about, which is easier and less confusing. Alright, thank you so much for watching this video, and on the next video we'll be talking about metallic hydrides.